Hi guys. Okay, so in this video, we are looking at problems 47 and 49. So that's from the chapter on gases, chapter 8 from the GOB, the Chem 30A course. Okay, so here 47. 47, you need to find the pressure in ATM. Okay, you are given the moles of helium gas, 2 moles. Okay, so write it like that. Temperature is given 27 degrees Celsius, volume is given. So important things here. First of all, look at the unit. ATM, that's standard, that's good. Moles. So if it was grams, then you need to convert to moles. Liters is fine. If something was in milliliters, you convert to liters. But now you're given something in Celsius. You need to convert that to Kelvin. So 273 plus 27. And that gives you 300. So this is the number you will use because the units should always be in Kelvin. So unit for the volume should always be in liters, temperature Kelvin, and the number of moles is the number of moles, not the grams. And then the pressure should be in ATM or, if millimeters of mercury. So here we are given this. So we need to find the pressure. So we know one thing. Volume, temperature, and the number of moles. So something we know, that is a value of R, and that is known. Now, this is a formula, PV is equal to N RT. So P is equal to N RT over V. Now, the value of R, this is known 0.08206 liters atmosphere per mole K. Okay. So one thing is, ideally, you should memorize. But if you cannot memorize, these things are in the handout. So on the handout, you should know how to access the information from the tables. So I have given you the handout with the tables. So for the value of R, you can access it from there. On the exams, I'm not going to give you the value of R, but you should take out the value from the tables. So R value. Why are you going to use this number? Because we need to find the pressure in ATM. If it was pressure in millimeters of mercury, then we would have used the different value of R. So pay attention to that. All right. The rest is just plugging in the numbers. So P is equal to N. So 2.00 moles times R. R is 0.08206. liters atmosphere per mole K. Okay, times the value of T, which is 300 degree kelvins, over the V volume. And the volume is 10.0 liters. So now look at these units. Moles and moles cancel out. K and K cancel out. Liters and liters cancel out. The only thing that is left is the ATM. And that's what you need to find for the pressure. So let's do the math. So when 2 is multiplied by 0.08206 times 300 divided by 10, you get the value of 4.92369236. Okay, so ATM. Okay, now which numbers to use here? 3 significant figures. This is also like 3 significant figures, 3 significant figures, and this one is 4 significant. No, actually, this is 5 significant figures. So the answer should be 3 significant figures. So 3 sig figs. If we do that, so we would need to keep these numbers, and 3 is less than 5. Therefore, 2 remains as is. So pressure is 4.92 ATM, and that is the answer. All right, let's look at the next one. Here you are given the grams of, here you're given the volume. Volume, 20 ml of oxygen gas. Pressure is given in millimeters of mercury and the temperature in degrees Celsius. Now the mass, you need to find the mass. So this is something for the mass. Find the mass. Now, in this case, mass of oxygen. So in this case, it's reversed a little bit. So in other words, if you look at it, P, so this is the formula, P V is equal to N R T. So here, R value is different. You're going to look at, because the pressure given is different. So the pressure is in millimeters of mercury. Therefore, the value of R is in the 62.4. Let me double check. I think it is 62.4. Yeah. So it is 62.4 liters times millimeters of mercury per mole K. Okay, so this is the value you will use because the value of pressure is in millimeters of mercury. So that's why you will use this number. Okay, the only thing is temperature. Add 273, always make it into a Kelvin. So 22 plus 273 is equal to 295 K. So you will use this one. Okay, now volume is in liters. So this is good. So liters is what we want. Kelvin is what we want. Millimeters of mercury is matches with the R value. So we will use those two. And the only thing that we do not know is the number of moles. Once we know the moles, then find the moles first. So find the value of N for oxygen first. And then second thing, convert those moles N for the oxygen to grams of oxygen. Okay, so that's because the question is asking her find the mass. So let's do this. So N rearrangement, N is equal to PV over RT. So here pressure is 845 millimeters of mercury. Okay, times the volume is 20.0 liters over the value of R, which is 62.4 liters millimeters of mercury per mole K, times the temperature T is 295 K. And so here you see the millimeters of mercury cancel out, liters and liters cancel out, right? K and K cancel out, and we are just left with the unit of mole. So let's calculate that. 845 times 20, and that gives you 16. So let's write this here, 16,900, right? Divide that by 295 times 62.4, and that is 18,408. So 16,900 divide by 18,408, and you get 0.918 moles. Okay, next is find it in mass. So here, anytime you're doing the grams to mole conversion, so you are going to need, so moles to grams conversion, you would need the molar mass of oxygen. Okay, so here's the molar mass of oxygen, molar mass of oxygen. So it's 2 times 16, and that is 32 grams per mole. So 0.918 moles of oxygen times 32 grams of oxygen is present in 1 mole of oxygen. So 0.918 times 32, and that gives you 29.378, and so it becomes 38 grams of oxygen, and that's the answer. Okay, so that is, let me just double check, 29.4. Yeah, so 29.4 also can be written, 29.40 grams of oxygen. Okay, so that's the answer. All right, next is, for the next video, we will look at the other problems that relate to the, 47, 49, and yeah, we will look into the other problems. Okay, so, all right, thank you.